This video is all about the second problem for BOD calculation. Now, assuming that the data in the previous problem, okay, from our first example problem, we already solved for the K. We're going to use that value in this second problem as K is equal to 0.1748 per day. We're taken at 25 degrees Celsius. Compute the rate constants at 16 degrees Celsius. Now, let's enumerate the given parameters. We are given with a temperature at 25 degrees Celsius with the value of rate constant of the oxygenation K is equal to 0.1748 per day. Now let's proceed with the solution. The first step is to solve for the value of K at 20 degrees Celsius. Now we're going to use this formula. We have the rate constant of the oxygenation at any temperature T is equal to K20 multiplied with theta raised to T minus 20. Now, our theta here is raised to this quantity as T minus 20. Now, we have different values for our theta. Since our temperature is at 25 degrees Celsius for this value of K, we're going to use this value for theta at 1.056. Now, this value is constant for temperatures that are greater than 20 degrees Celsius. Whereas on the other hand, say for example, if we're going to solve for the K at 16 degrees Celsius, we're going to solve for the theta, or we're going to plug in the value for the theta at 1.135 since it falls within the range of 4 degrees Celsius to 20 degrees Celsius. Now, let's solve for the value of K20 here for this temperature 25 degrees Celsius with a value of K at 0.1748 per day. All right, let's plug in the values. This gives us 0.1748 is equal to the unknown K20. This is the first step, solve for K20, times, since this is at 25 degrees Celsius, we're going to use the value of theta here at 1.056 raised to our temperature here, 25 degrees Celsius minus 20 degrees Celsius. Now, if we're going to divide both sides of equation with 1.056 raised to 25 minus 20, this gives us with the following confirmation at K20 is equal to 0.1748 all over 1.056 raised to 5. Further simplifying the values gives us 0.1331 per day for the K20. Now we're going to use this value of rate of constant of the oxygenation for 16 degrees Celsius. Now, okay, let's solve for the value of rate of constant at 16 degrees Celsius. We're going to use again this formula. So K at 16 degrees Celsius, okay, is equal to K20, which is solved earlier at 0.1331. So since this is 16 degrees Celsius, we're going to use the value of theta at 1.135. This is raised to 16 minus 20. Further simplifying the following values gives us the following confirmation at 0.1331 times 0.6026, or our final answer for the rates of constant for the oxygenation at 16 degrees Celsius as 0.0802 per day.